If you're a Java developer, you know the feeling. You're staring at your code, you need a map, but which one? There's like a dozen of them. Well, today we're going to settle it. We're going to help you choose the right champion for any programming challenge you've got.
Okay, let's just level set for a second. The absolute basics. What is a map? It's just an object that stores key value pairs. The classic analogy is a dictionary, and honestly, it's perfect. You have a unique word, that's your key, and it points to one single definition. That's your value. Simple, powerful, and you use it everywhere.
But here's where it gets tricky, right? The Java development kit doesn't just give you one map. It gives you a whole arsenal of them. And picking the wrong one? Well, that can lead to some nasty bugs, terrible performance, or just code that's really confusing to come back to later. So how do you pick the right one?
That's what we're here for. We're going to put the most important maps through a series of challenges. Let's call it a gauntlet, and see which one comes out on top for different situations. Let's get this thing started. First step in the gauntlet, our first contender is the one everybody knows and loves, the HashMap. This is the one most of us reach for by default, and for good reason. It's our all-rounder, the baseline we're going to measure everyone else against. Okay, so HashMap's greatest strength is also its biggest trade-off. It is incredibly fast. We're talking O1, or constant time performance. All that means is it takes the same amount of time to find an item whether your map has 10 entries or 10 million. It's blazing fast. But to get that speed, it makes a couple of sacrifices. First, it gives you absolutely zero guarantees about the order of the elements. And second, it is not thread safe. Don't use it with multiple threads at the same time. So, what do I mean by no guaranteed order? Well, look at this. Let's say you add apple, then banana, then cherry to your map. You'd probably expect to get them back in that same order when you loop through it, right? Nope. With a hash map, you might get banana, then cherry, then apple. The order can seem totally random because internally it's organizing everything for one thing and one thing only: raw speed. So here's the bottom line. If all you need to do is shove data in and pull it out as fast as humanly possible, and you could not care less about the order, HashMap is your champion. It's the undisputed king for general-purpose, high-speed lookups. Period. But what happens when order does matter? And let's be honest, it often does. This brings us to the first real challenge in our gauntlet. HashMap, for all its speed, is out of the running. So who's going to step up? Now, these are two really common needs. Sometimes you just want a reliable, predictable order, like the exact order you put things in. Other times, you need the map to be constantly, automatically sorted by its keys. And you know what? These are actually two different problems that require two different champions. And first to step up to the challenge is LinkedHashMap. Now, this one's clever. It's built right on top of HashMap, so you keep all that amazing speed, but it has a secret weapon. Under the hood, it's quietly maintaining a linked list. Think of it like a hidden thread that connects every single item in the exact sequence it was added. It preserves that order perfectly. And the difference here is, well, it's night and day. HashMap's order is a chaotic free-for-all. LinkedHashMap gives you a rock-solid guarantee. You will always get your items back in the exact order you put them in. This is awesome for things like a simple cache or tracking a sequence of events over time. But what if you need the items to always be sorted by the key itself? For that, we need a totally different champion. Meet TreeMap. It couldn't care less about insertion order. Instead, it uses a really cool data structure called a red-black tree to automatically keep all of its entries sorted for you. The trade-off? A tiny performance hit. Its O of log n time means it gets a little bit slower as you add more items, but it scales really, really well. So let's make this crystal clear. If you put cherry, then apple, then banana into both of these maps, you get two very different but very predictable results. LinkedHashMap remembers you put them in that order, so it gives them back to you in that order. TreeMap, on the other hand, just automatically sorts them and gives you the natural alphabetical order. Two different champions for two different kinds of order. All right, on to our next challenge, and this is a big one in modern software: concurrency. What happens when you've got multiple threads all trying to read and write to your map at the same time? This is the classic dilemma, isn't it? If multiple threads start messing with a standard hash map, you're gonna get data corruption. It's just a matter of time. But if you try to protect it with big, heavy-handed locks, your application's performance can just fall off a cliff. We need something that's both safe and fast. The way this problem was solved over time is actually brilliant. The old way, using a class called hashtable, was like having a library with only one master key. Only one person could be in the entire library at a time. You can imagine the bottleneck. The modern way, concurrent HashMap, is like giving out separate keys to every single aisle. Multiple people can read and write all at once, as long as they're not in the exact same spot.
So yeah, the undisputed champion for concurrency is concurrent HashMap. It was built from the ground up for high performance in multi-threaded code. It's got the speed of a HashMap, but with fantastic built-in thread safety. Just remember two things. Like a HashMap, it doesn't guarantee order, and it's very strict. No null keys or values allowed. Okay, we've covered the main contenders, the heavy hitters. But every great team has specialists. So now that we've seen the all-rounders, let's do a quick lightning round of some special ops tools designed for very specific missions. First up, enum map. If you know for a fact that your keys are all going to come from a single enum, like days of the week or a fixed set of status codes, this is your champion. It's a hyper-specialist. It ditches all the complicated hashing stuff and just uses a simple, compact array under the hood. The result? It is unbelievably fast and memory efficient for this one specific job. Next is a really clever one, weak HashMap. It holds onto its keys weakly. What that really means is if the only thing in your whole program pointing to an object is the key in this map, the Java garbage collector can just swoop in and clean it up. When that happens, the map entry just vanishes. It's basically a self-cleaning map, which is absolutely perfect for memory-sensitive caching. And finally, a quick word of warning about the old hash table. I'm just going to say it, it's obsolete. It's a relic from Java 1.0. That method of locking the entire map for every single operation is a massive performance killer. So for any new code you write today, the choice is simple. Just always use concurrent HashMap instead, please. All right, we've been through the gauntlet. We've seen the champions rise to their challenges, and we've seen the specialists take on their unique roles. Now, let's put it all together into one final, actionable guide. This is it. This is your cheat sheet. For your default general-purpose needs, your champion is HashMap. Need to maintain insertion order? Choose LinkedHashMap. Need everything to always be sorted by key? That's a job for TreeMap. Any multi-threaded work? Just go straight to concurrent HashMap. And hey, what if you need both? Thread safe and sorted? There's a champion for that too, concurrent skip list map. And finally, if your keys are an enum, the hyper-optimized enum map is your winner, hands down. And there you have it, a full tour of the Java Maps landscape. Now, the next time you need to store key value data, you're not just picking a map, you're picking the right champion for the job. So which one are you going to choose for your next project?